Alright, so we've got this nice quadratic x plus 5, x minus 1, y equals x plus 5, x minus 1. So you can see the zeros are negative 5 and 1. So if I draw a parabola, it's not to scale, so negative 5 and 1. So that's a space of 6. So if I halve that, I've got a space of 3. So if I go 3 back from negative 1, I've got 0, sorry, from, I don't know why I wrote negative 1. You would have fixed me if I could hear you. There you go, 1. So 0, negative 1, negative 2 should be right in the middle. Alright, so let's put that, which would be the stationary point, right? So that's at negative 2. If I do sub in negative 2 there, we've got a 3 here and negative 3 here. So that would be negative 9. So this point here, oops, that point here, I'm going to make minus 2, minus 9. Which makes sense. All right, where do the graphs? All right, so we also have to draw the reciprocal. And we know for the reciprocal that wherever x in my original function, wherever my f of x is 0, I can't have 0 on the bottom. So you can see here that these are going to become asymptotes. So asymptotes at 1 and minus 5. We also know that where the graph's positive, so where f of x is positive, 1 on a positive is still a positive, so it's still going to be in this bit here, in this region here, in this region here, right, because it's positive. And then 1 on a negative is still negative, so all this down here is still going to be down here somewhere. It's going to be in the negative region. All right, we also know as f of x gets larger and larger and larger, our 1 on f of x is going to get smaller and smaller and smaller, and the opposite as well. So we know that this part is going to go like that, and this part is also going to go like that because of that fact. And we can take a point, for example, this stationary point is at minus 9, and 1 on minus 9 is negative 1/9. So I know that that point is going to go up, let's put it here, which is now going to become minus 2, negative 1/9. All right, that point there. And to the right of that, well, let's look at the y-intercept as well. Sorry, I'll do that in blue so you can see the y-intercept. The y-intercept we can just get from there is the constant, so it's negative 5. So 1 on negative 5, which is, so we're comparing it to negative 1/9, so negative 1/5. So it's going to be hard to put, but let's just put it here. So negative 1/5 is about there. So I should put that in purple. So that will be the new y-intercept. So you can see again where it's negative 1 on f of x, it has to stay negative. So it's going to come down like that, and it's going to come down like this as well. So it's quite a flat, it's probably a bit flatter there. It's a bit flatter, as it were. So now it does say to see where they intersect. So you can see they would intersect, I put it in green, here and here. So if we want to find where they intersect, we need both those curves. So we've got x plus 5, x minus 1, and we're seeing where it intersects with 1 on x plus 5, x minus 1. Right, so if we multiply across, we've got x plus 5, x minus 1 all squared, equaling, where does that equal 1? We could look at where that equals 1. We could do, so different ways to do it. Many different ways to do it. Find and analyze, hence sketch the graph. All right, shall I? All right, so probably if I were to expand, we've got x squared I'll do it this way, plus 4x minus 5, and we're squaring that, and then we're equaling 1. So we're going to get, if I square all of this, x,